Week 2, lesson 1. All right, so this is saying if there's a direction vector, right, that has a certain direction in the x direction, a certain number, I should say, and a certain number in the y direction, then there's something called a normal vector that looks like this. So let's actually put some numbers in there and see if we can kind of make that make a little bit more sense. So if our original direction vector was, let's just say 1, 3, that means that the normal vector would be -3, 1. So any guesses what you think normal might mean? Here's a hint. Think about slopes. Normal means perpendicular. All right, so let's do an example of this. So if I graph this direction vector, so again, pick a starting point, go right 1 and up 1, 2, 3, 4. And its corresponding normal vector based on this definition would be -4, 1. So let me pick a point. This means I'm going to go left 4, 1, 2, 3, 4, and up 1. Then you can see that they are, in fact, perpendicular. Okay, perpendicular. So with that being said, it says, let's find the equation of the line in slope-intercept form passing through this and with this direction vector. Okay, so let me write what I know. The direction vector is 2, -1. That's the direction that my line is going to go through after it goes through that ordered pair. So really, it's almost like I have a slope. Just keep in mind that this is the change of x, and this is the change of y, and we are used to slope, right, back from Algebra 1, being change of y over change of x. Okay, so now that I've got this point and I've got this slope, there's this magical form called point-slope form, so we're going to use that. It's going to be y minus y equals m times x minus x. And then I'm going to distribute -1/2 x minus 3/2. And when I move that -4 to the other side, I get y equals -1/2 x plus 5/2. Okay, scooting it up. All right, and this one's really, really similar. Again, we're finding an equation of a line in slope-intercept form. They've given us an ordered pair, but this time we have a normal vector. Okay, so if the normal vector is 3, 5, that means the direction vector is -5, 3. Which means this is the change of x, and that's the change of y. So the slope that we want to use, actually, is going to be 3 over -5, or -3/5. All right, and then we kind of go and do the same thing. Y minus y is equal to m times x minus x. I'm going to distribute. And I'm going to add the 4 to the other side. All right, scooting this up. Okay, so now, again, it's similar, right? Similar, but this is a line given in a different form, all right? So I'm going to change it. I'm going to kind of write this thing up in this particular form, 1 plus and -2 plus. And the reason I'm doing that is so that I can write it this way. Again, this is equivalent, but it might make a little bit more sense. If you remember writing writing lines in vector form, right? I needed a starting point and I needed a direction. So now that I have a direction and I have a point, I should be able to write a new vector equation, right? Vector equations look like this. And they have a starting point, which was given to me. And they give me a direction, which I had to find from here. All right, and the last one. All right, sort of. In fact, if you look really close, I'm pretty sure those are the exact same. Yeah, they're the same. All right, so if I have this direction vector from the previous example, let me switch colors. If I've got this direction vector, but this time I want it to be perpendicular, that means I want the normal vector, which would be -1, 1. And now I can write the vector equation. Vector equation means I need a starting point, which is negative 4, 1. It was given right here. Plus a parameter. And I just need the direction this one's going. This one's going in the direction of negative 1, 1.